Here is the problem. You get a stick and break it randomly into three pieces. What is the probability that you can make a triangle using three pieces? Okay, let us solve this. Let the length of the stick is 1 unit. Let us denote the left end of the stick with a 0, right end with a 1. Okay, let us say this is our stick, left end with a 0, right end with a 1. The length of the stick is 1 unit. Okay, now let x and y denote the location on the stick where we break randomly. To make into three pieces, we need to select two locations on the stick. Let us say this is x, this is y. Okay. Now, then length of the three pieces that we can get are x, y minus x, 1 minus y. These are the length of the three pieces that we can get. And these three pieces make a triangle if and only if length of each piece is less than 1 by 2. Because if at least one of the piece having greater than 1 by 2 means some of the remaining two pieces going to be less than 1 by 2. Then it will not make a triangle. Okay. So these three pieces make a triangle if and only if length of each piece is less than 1 by 2. So these pieces make a triangle if and only if 0 less than x less than 1 by 2, 0 less than y minus x less than 1 by 2, and 0 less than 1 minus 5 less than 1 by 2. Okay, this is equivalent to, and 0 less than x less than 1 by 2. If I combine these two, okay, from this I can write y bigger than 1 by 2. From this I can write x less than y less than x plus 1 by 2. And x already less than 1 by 2. So better lower bound going to be this 1 by 2. So I can write 1 by 2 less than y less than x plus 1 by 2. Okay. So these three pieces make a triangle if and only if 0 less than x less than 1 by 2 and 1 by 2 less than y less than x plus 1 by 2. Okay. So fine. Next. Now let us find out the joint PDF of x and y. Here x and y are going to be random variable. They are going to be continuous random variable. Now the joint PDF of x, y going to be product of marginal PDF and conditional PDF, because the conditional PDF f of y given x, how do we write? Joint PDF by marginal PDF of x, right? So if I cross multiply, then I can write joint PDF of xy as marginal PDF into a conditional PDF of y given x. Okay, that's why joint PDF of xy we can write marginal PDF of x into conditional PDF of y given x. Here x follows uniform distribution over the interval 0, 1, because we initially pick randomly a location from 0 to 1. Once we pick the location x, the y given x will follow uniform distribution over the interval x to 1, because we pick a location from x to 1, right? That's why this joint PDF going to be, this fx of x going to be 1 by 1 minus 0, as x follows uniform distribution over the interval 0, 1, and the conditional PDF of y given x going to be 1 by 1 minus x, because it is a uniform distribution over the interval x to 1. So with support 0 less than x less than y less than 1, because x always less than y, right? Okay, fine. So this is going to be our joint PDF. Okay, 1 by 1 minus x for 0 less than x less than y less than 1, 0 otherwise. Okay. Now let us compute the probability of three pieces making triangle. Now probability of three pieces making a triangle equal to probability of 0 less than x less than 1 by 2 and 1 by 2 less than y less than 1 by 2 plus x. Okay. Now we simply have to double integrate our joint PDF over this region. Okay. So what we do, we simply integrate joint PDF over this region. 0 less than x less than 1 by 2, 1 by 2 less than y less than x plus 1 by 2. Okay. Fine. So our joint PDF is what? 1 by 1 minus x. Okay. Our y limit is going to be 1 by 2 to x plus 1 by 2. First we are integrating with respect to y. Our x limit is going to be 0 to 1 by 2. Okay. So since we are integrating with respect to y, so 1 by 1 minus x we are getting out. So if I integrate this one, I get integral of y with the limits 1 by 2 to x plus 1 by 2. This gets simplified to x. Okay. So this is going to be x. So next we have to integrate x by 1 minus x with respect to x from 0 to 1 by 2. Okay. This x by 1 minus x, first we can write 1 by 1 minus x minus 1. Now let us integrate. Integral of 1 by 1 minus x going to be minus log 1 minus x with the limits 0 to 1 by 2, and integral of 1 going to be x, okay, with the limits 0 to 1 by 2. Okay. Now after applying this limit, the whole thing is going to be log 2 minus 1, whose value is 0.193147. Okay. This is what we got. Fine. Now let us try to simulate the experiment to verify if our solution is correct. Okay. Simulation of breaking stick experiment. Here I am taking n equal to 1 million. I am going to repeat this experiment million times, and I am going to get the frequency of making triangle in this million trials. Okay. I am starting with a frequency 0. So in this for loop, okay, each time I am going to pick a random number in the interval 0, 1 and putting it in x, and I am picking a random number from the interval x to 1 uniformly and putting in y. So these are the locations I mentioned, x and y. Then I am going to get the three lengths a, b, c. A going to be x, b going to be y minus x, c going to be 1 minus I. A, b, c are length of the three pieces. Okay. Now these three pieces make a triangle if and only if we know that a plus b bigger than c and b plus c bigger than a and a plus c bigger than b. If that happens, I am increasing my frequency by 1. Okay. Once I am done with the loop, I am going to print this f by n, that is relative frequency for making this triangle. Okay. Now let us see what is the relative frequency that gets printed. Let me run here. Okay, 0.192526. It's pretty close to actual probability that we got. Let me run again. 0.19286. 0.192581. 0.193939. See, it's pretty close to actual probability that we got theoretically, right? So our approach must be correct. Okay. Now let me stop. Thank you.